Hi everyone, welcome back. Today we're looking at part 2 of module 5 for Workplace 11 Math. This is geometry calculations. We're going to start with what's hopefully a review of units in the metric system. The official system of measurement for almost every country in the world, including Canada, is called the International System of Units, or SI, but it's more commonly known as the metric system. The units for length are the base unit is the meter, and it's approximately your notes say the length of a pace or 2 steps, but that's actually longer than a meter. I would say a giant step. It's the length of a giant step. It's also interestingly about how as high as a doorknob is normally off the ground. That's a pretty standard height in most things. A centimeter is about the width of a baby finger, an adult baby finger. And a millimeter is the width of a paperclip. Capacity or volume is measured in liters, and a liter is like a 1 liter jug of milk, or carton of milk actually. Let's put that right, it's a carton of milk. A centiliter is about half a cup. Oops, half a cup. And a milliliter is like an eyedropper full. Mass is measured in grams, and a gram is about how much mass and weight are used interchangeably on planet Earth. Mass measures how much material a thing has. We use it for weight. It technically doesn't measure weight, but on planet Earth we use them interchangeably. It's a science concept. I'm not going to worry about it here. But a gram is about how much a paperclip weighs. It's really not very much. And a kilogram is about a 1 liter carton of milk. Okay, just so you have some perspective on that. All right, some practice here. Do these questions, pause the video, do these questions, check them, come on back. I'll meet you on page 1, actually. I know we're on page 12 right now, but for some reason the pages start renumbering. So page 1. See you in a few. Part B, reading measurements in the metric system. Measuring with a metric ruler is usually done in centimeters or millimeters. And metric rulers are fairly easy to read. Answers and measurements are recorded in decimals, not fractions, always. Okay. And if you look at your ruler, they always say on them what they're measuring. So this tells you that each of these big numbers here is a centimeter, and that means that each of the little tick marks is a millimeter. All right. So on this example, the arrow is pointing at 2.8 centimeters, which is also 28 millimeters. All right, so here's some practice for you. Notice that it says to state the length in centimeters and millimeters. That means you're going to give 2 answers for each one, okay? We would never say here, we would never say that this is 2 centimeters, 8 millimeters. That's just not a thing you do in metric. Okay, we do that with inches and feet, but we don't do it in metric. Metric is always a single unit. But for these ones, we want you to measure it 2 different ways. Once, how many centimeters is it? And then separately, how many millimeters is it? Okay, so there's a couple of practice questions there. Do those, and I will meet you on the next page. All right, section C, or part C, we're going to do perimeter. So the distance around any shape is known as the perimeter. To calculate the perimeter, you simply add the lengths of all the sides. Perimeter is always in linear units. So that means it's centimeters, meters, and so on, as opposed to centimeters squared. Okay. So here's an example. Perimeter equals sum of all side lengths. So we're going to add those side lengths up. What I like to do is on my drawing put a mark somewhere so I know where I started. So it's going to be 5 plus 7 plus 4 plus 6 plus 4. I'm just adding them up in order. And when I'm writing it down, I probably don't need that mark, but if I do it in my calculator, it's really handy to know where I started and where I'm going to end. All right, if I add those up, I get 26, and I need my units, which is meters. So there's my answer. The formula P equals sum of all sides works for all shapes, any shape, no matter what, it works. However, there are a few shapes that are so common they have their own specific formulas, and they'll all be on your formula sheet. For a rectangle, the formula is P equals perimeter equals 2 times the length plus 2 times the width. It doesn't matter which is called the length and which is called the width, although length is usually the longer side. So let's do this here. P equals 2L plus 2W. And I always do my L's as like a scripted L so that you don't confuse it with a 1. And I'm going to say that this is my length and this is my width. So this becomes 2 times 6 plus 2 times 4, which is 12 plus 8, which is 20. And then I need my units. It's centimeters. There's my answer, 20 centimeters. All right. Important when you're solving a word problem, always, 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 always draw a diagram to help you. Won't always be necessary, but it usually will, and it's a good habit to have. All right. For all of these questions, there are 3 steps. I'm going to add another one up at the top. Draw a diagram. Write the formula. Put the numbers into the formula and write your answer with units. Okay? That's that for here. Do the practice questions and I will meet you on page 5. All right, we're going to talk about circles now. The perimeter of a circle has a special name and formula because you can't measure the sides of a circle, not with a ruler anyway, you can with the tape measure. So sides of a circle. The perimeter of a circle is called the circumference. And it's just the distance around the circle, right? The formula for circumference, there are actually 2 and you can use either one. One is C equals 2 pi r, which means 2 times pi times the radius. or you can use C equals pi d, which is pi times the diameter. So the diameter is the distance across a circle, all the way across, through the middle is the diameter. And the radius is from the center to the outside of the circle, okay? And pi is on your calculator. It's approximately 3.14, but just use the button on your calculator, okay? Otherwise, you won't get the exact answers that we have in the answer key here. All right, just to fill out these notes, this diameter is the distance across from one side of the circle through the center to the other side. Radius is the distance from the center of the circle to a point on the outside. So that's what I did up here. I did from the center of the circle to any point on the outside. And the radius here is the same length, and the radius here is the same length, and the radius here is the same length, okay? And it is always half the size of the diameter, half the length of the diameter. All right, let's do an example here. We can calculate it using either formula. I'm going to use it doing both just to show you. So formula 1, C equals 2 pi r. So it equals 2 times pi times the radius this time is 7. And that comes out to 43.98 meters. And if I do it using the other formula where C equals pi times diameter, it equals pi times 14, and I get 43.98. So take a minute and try that on your calculator. Make sure you can find the pi button. If you can't, ask for help because it's there if you've got a scientific calculator. And go and do the practice questions, and I will meet you on page 8. Next topic, area. In geometry, area refers to the measure of a region. It's measured in square units, such as centimeters squared, meters squared, inches squared, and so on. The area of a geometric figure is the number of square units needed to cover the interior of that figure. Imagine trying to cover the space with little paper squares. If your squares are all 1 centimeter squared, then how many of those would cover is how many centimeters squared the area is. These formulas are going to be provided for all the quizzes or work that you do this year, and they're on your formula sheet. The area of a rectangle is the length or base times the width or height, depending on how you're looking at your shape, right? So if this is our length and this is our width, then the area of this rectangle is length times width. So it's 15 times 6. So it equals 90, and that's meters squared. All right. Next page. In a square, all the sides have the same length. So the area is side length times side length or side squared. So here's S, this is S. So area is side times side or side squared. So it's 7. Oops. It's 7 times 7, which is 49, and it is centimeters squared. All right. So just to think about that, what this actually is, if this is 7 centimeters across here, it means that there's like 1, 2, 3, 4, 5, 6. We're going to pretend those are all the same size. And then there's 7 going this way. Okay, and again, we're going to pretend those are the same size and they're straight. So here's 1, 2, 3, 4, 5, 6, 7. It's 7 centimeters along there, and it's 1, 2, 3, 4, 5, 6, 7 centimeters along there. So if each of my so-called squares is 1 centimeter by 1 centimeter, it's 1 square centimeter, right? It's 1 centimeter square. And there's 49 of them. Okay, that's how area works. All right, triangle is any three-sided figure The area of a triangle is 1/2 the length of the base times the height. And you can write it as 1/2 base times height or base times height divided by 2. Either of those works. Area equals base times height divided by 2 equals 6 times 9 divided by 2 equals 27 centimeters squared. And again, it's squared, okay? And if you want help remembering that formula, make this into a rectangle. All right. So there's a rectangle. This is our length, and this is our width. And if you cut it in half like this, down the middle there, down the height line, this area here is half of that rectangle. And this area here is half of the rectangle that was on the left. So the triangle is half the area of this whole rectangle. So it's length times width or base times height divided by 2. That's where the formula comes from. All right, there are there's a little bit more here. The formula works for all triangles as long as the base and the height are perpendicular to each other. They don't have to be inside the triangle. All right, I'm actually just going to look at this example here, this practice question. Psst, the base is this length. Okay, it's how much of it's actually the triangle. It's not this part, just this part. Okay, all right, do those 2 practice questions, check your answers, and come back, and we'll look at circles. Okay, a circle has no sides. Pretty hard to figure out a formula for the area of a circle, so we give it to you. It's pi r squared, where r is the radius of the circle. So for example, this one we're given the radius. Whenever I have a circle, I always like to write down what the radius equals. It's something that helps me. So area equals pi r squared. So that is pi times 6 squared, which on my calculator I get 113.1 centimeters squared. Okay, and hopefully you saw the thing further up that says that all of the calculations you do using pi in this book, use the pi button on your calculator and round to 1 decimal. All right. Example 2. This time we're given the diameter, so I need to calculate my radius, and the radius is diameter divided by 2. So my radius is 14 divided by 2, so my radius equals 7. All right. Area equals pi r squared equals pi times 7 squared, and that's 153.9 centimeters squared. All right, so make sure that you're using the radius and not the diameter. Now we're going to look at what we call composite shapes. A composite shape is one made up of two or more simple shapes. To find the area of a composite shape, you just add up the areas of the simple shapes, or sometimes you subtract one area from another. We'll do an example of each kind. None of these are difficult, but they do require some organization. All right, because you could do all the pieces of them. So this is just a matter of putting the pieces together. So finding the area of this composite shape. So the area is going to be the area of the triangle plus the area of the rectangle. And the area of the triangle is base times height divided by 2, and the area of a rectangle is length times width. So let's look at the triangle. The base of the triangle is this line, this one I'll do in yellow right here, which doesn't have a measurement given, but it's the same as this one, right? So it's 8. So the area of the triangle, the base is 8. The height is 3.5, even though it's turned on its side, it's still the height of the triangle, divided by 2. Plus, for my rectangle, the length is 8 and the width is 1. So that equals 14 plus 8, which is 22, and its area, so it's meters squared. Another example, find the area. Oh, this is practice. Sorry, this is practice. Do this question, come back for the next example. Okay, this one, we're going to find the area of the shaded part. So the area of the shaded part, I'm just going to shade, is the area of, we have no way of calculating this area. We don't have a formula for that. We don't know how to do that. So it's what we're going to calculate though, because we can, is the area of the whole circle, and we're going to subtract the area of the square. All right, and that will leave us with the shaded bit. So the area of a circle is pi r squared. The area of a square is side length squared. So pi, what's the radius of our circle? Well, we've actually been given 14. This is the diameter, right? That's the distance from one edge of the circle all the way to the other through the center. So my radius is diameter divided by 2, which is 14 divided by 2, which is 7. So this is going to be pi times 7 squared. And the side length of my square is 10, so minus 10 squared. So this equals 53.9, and it's in feet, so it's feet squared. All right. So the tricky part of that, if you even want to call it that, was figuring out what shapes we can use and how to combine them. All right. Do the practice. A couple of pages of practice this time, and I will see you on page 16. All right, now we're going to look at surface area, which is abbreviated SA, and it refers to the area of all surfaces of a three-dimensional object. Okay, it's the combined area of all the surface. Surface area is always expressed in square units. Think of covering the surface with little squares of paper. And the formula for the surface area is the same for all objects. It is the sum of all the areas of all the surfaces. That is, you find the area of each face, each side, each surface, and add them all up. All right. Um, it's as we saw with perimeter, there's one formula that does work for all situations, which is this one. It's the sum of all the surfaces, sum of the areas of all the surfaces. Figure them out, add them up. But a lot of shapes have simpler formulas than that because we use them all the time. Well, and because it's easy to come up with a formula for them. I'm thinking of a chess piece. That would be really hard to find a formula for the surface area of a chess piece. But a cube, that one's easy. You'll notice that you have formulas for the surface areas on the formula sheet. Make sure you understand that these are derived from calculating the sum of all the sum of all the side areas all right, and use them. To find the surface area, you always use the following shapes. You use this program, this plan. Write the formula. Put the numbers into the formula. Answer with units. That should sound familiar by now. All right, let's do a couple of examples. A rectangular prism. The formula that we have for that, the surface area is twice the width times the height plus the length times the width plus the length times the height. It's kind of ugly. Let's make some sense of that. Let's label this one the length, this is the width, and this is the height. All right, 7 millimeters is this one going up and down here. All right, so the width times the height is the area of this little side bit here. Okay, because this is also the height here, right? The length times the width would be the area of the bottom, right? The bottom rectangle. Which is hard to color neatly with this thing, but there you go. And the length times the height, is the front of it, or it's the back. I'm gonna color the back because it's the same, right? It's a rectangular prism. And actually, I'm gonna redo this little side piece in yellow because it got covered up. There we go. Okay, so this is the length times the height is, oops, wrong one. All right, and then you multiply it by 2 because there's two sides that are the same, like the top and the bottom are the same, the left and the right, the front and the back are all the same. All right, so let's do this calculation. So this is going to be 2 times the width, and this is where it's important that you've labeled them on your drawing because that lets you, then you remember which one you've labeled as which. So the width times the width is 6 times the height is 7 plus the length is 13 times the width is 6 plus the length is 13 times the height is 7. And just as a quick double check, each number should be in there twice. All right, so we've got the 6 and the 6 is twice, and the 7 is in there twice, and the 13 is in there twice. All right, and then when you do this calculation, pay attention to where the brackets are, okay? Make sure that you do the calculation inside the brackets first and then multiply it by 2. That's the biggest mistake that I see students doing for this one, is they just multiply this first thing by 2 and then add these other ones on. It's not. You need to do what's in the brackets first, all right? So our answer to this is 422 millimeters squared. A cube is a special type of rectangular prism where all the side lengths are the same and therefore all the faces are the same. And you can calculate the surface area of a cube in exactly the same way you did for the rectangular prism. 2 times the width times the height plus the length times the width plus the length times the height. Or you can do the surface area is 6 times the area of one face, this is different than is in your notes, I will tell you. And since each face is a square, the area of the face is side times side. So it's 6, whoops, 6 times the side length squared, okay? And in this case, that's 6 times 6 squared, which is 216 yards squared. All right. This first 6 here comes from there being 6 sides that are all the same. And the other 6 is because it happens to be the length of the side. All right. Cylinder is the shape of a soup can. And the surface area of this has a formula that you can just use. And that is that the surface area is 2 pi r squared plus 2 pi r h. And just for reference here, the 2 pi r squared is the two circles, the top and the bottom, okay, the top and the bottom of the can. And the 2 pi rh is the side. It's like the paper of the can, you know, the label. Okay, so it's all of this part is here. All right. So we just plug in the numbers. It's 2 times pi and the radius. This case, the diameter is 6. Okay, my hand and my mouth are not on the same plan today. The diameter is 6, so the radius is the diameter divided by 2, which is 6 divided by 2, which is 3. So that's the number that we're going to use here. It's 2 times pi times 3 plus, or 3 squared, sorry, it's the radius squared, plus 2 times pi times the radius times the height. You plug that all in your calculator, you get 207.35 yards squared. And again, squared because we're talking about an area. A cone has its own formula as well. And the surface area of a cone is pi r squared plus pi rs. And S in this case, this is S. It's called the slant height. And it's basically how long is the slanted part of the cone. All right. And as in the cylinder, the pi r squared is the circle at the end, or circle, yeah, at end, that works. And again, with my hand. And the pi rs is the, it's the cone part, if that makes sense. It's like the, this part here. Okay, that's pi rs. All right, and you do need to know that because sometimes you're only asked to calculate the side area of the cone and not the bottom, so you would just use the pi rs. Okay, but in this example, we're doing the whole surface area, so that is pi times 7 squared. This time we're given the radius, so we don't need to find it. And then it's pi times 7 times 19. Plug that in your calculator, and it's 571.77 inches squared. A sphere is what we call a ball shape, and its formula is surface area equals 4 pi r squared, and you'll always be given that. And showing you where that formula comes from is way beyond the scope of this course. It's actually calculus level work to show you how that one is figured out. I'm not going to do that. So 4 times pi times 7 squared. My calculator tells me that's 615.75 inches squared. And last one for this part is the pyramid. And it has a formula as well. Surface area equals 2bs plus b squared. So the b squared, oh, this is specifically a square-based pyramid, which happens when the bottom of your pyramid is a square. This area here in red is square. So that's the red square. I'll write that. Okay, b squared. So this is also 4 yards here. And the 2bs is the slanted part. And b is the base length. And s is again the slant height. And that is not the inside height of the pyramid. It is how long is the height of the triangle that's on the side of the pyramid, actually. The inside height of the pyramid we use for volume, which we will, I'm assuming we will get to. All right, so let's plug some numbers in here. So this is 2 times 4 times 10 plus 4 squared. So my calculator gives me 96 yards squared. All right, go ahead and do the practice questions, and I will see you on page 24. Okay, part G, volume of prisms excluding pyramids and cones. So we're just going to do a few shapes for now. A volume refers to how much space something takes up. Volume is expressed in cubic units. Imagine filling the space with little cubes. How many cubes does it take? You probably learned a formula for volume in elementary school. Volume equals length times width times height. Remove that from your brain because it only applies to boxes, or what we call rectangular prisms. Okay, we need a more general formula that applies to all the prisms. So let's start by figuring out what a prism is. A prism is a 3D shape with two identical parallel surfaces called bases and sides that are parallelograms. Prisms are named for the shape of their base. Common examples include a rectangular prism, a cube, which is a special kind of rectangular prism, triangular prisms, and I'm just going to pause for a moment because these drawings are not very good because the base is actually the end here. That's the side that there's the two parallel sides, and the base here is this one, not the one that was shaded in the drawing. But I happen to know that the internet doesn't have any royalty-free drawings of triangular prisms that are shaded properly, because I've looked. A pentagonal prism, this one's got a pentagon as the base, and a cylinder is like a prism because it's got those two cylinders. It's actually technically not a prism, but we calculate it the same way as a prism because the sides are not parallelograms. Anyway, the formula for the volume of any prism is volume equals the area of the base times the height. All right. So you've got a formula for the volume on your formula sheet. And understand that these are derived from calculating the area of the base and multiplying that by the height. So if you're given formulas, you can use the formulas. All right. So for example, a rectangular prism, volume equals length times width times height. And that's okay. If you think about this, the area of the base is length times width. So that's still following our rule. So in this one, the length, we can label these. This is L, this is W, this is height. So this becomes 6 times 2 times 4, which is 48 centimeters cubed. For a cube, it's just a special kind of rectangular prism, so it's length times width times height. So that's 6 times 6 times 6, which is 216 yards squared. You can also use a formula that says volume is side length cubed, which is then 6 cubed, which is still 216 yards cubed. I wrote squared. It should be cubed. My bad. Of course it's cubed because it's made up of little cubes. Okay, for a cylinder, the volume is pi r squared h. That's the area of the base, which is the circle, pi r squared, times the height of the prism. This example gives us the diameter is 12, so the radius is 12 divided by 2, which is 6. So this becomes pi times 6 squared times 10, which is 1131.0 centimeters cubed. All right, there's some practice for you. Oh, I'm just gonna quickly on this first one, you're just counting the cubes, okay? So figure out how many cubes there are by looking at the drawing, okay? You're not using a formula, you're just gonna try and count them. You can't see them all, you need to figure out how many are there, but you're just counting. All right, and then there are some questions where you're doing actual calculations using the formulas. Okay, go do that practice work, and I will see you on page 31. Okay, now we're going to do the volume of pyramids and cones. A pyramid and cone are 3D shapes that have a polygon base and sides that come to an apex, also known as a point. You have formulas for these on the formula sheet, and notice that these formulas all have the fraction 1/3 in front of the equation. So, which is interesting. It works out that the volume of a pyramid is 1/3 the volume of the rectangular prism that it would fit inside. Weird, eh? Same as for a cone. It's 1/3 the volume of the cylinder that it would fit inside. Anyway, for all the questions, you're going to follow the steps, write the formula, put numbers in, and answer with units. So a pyramid, the volume is length times width times height divided by 3. So that is 6 times 7 times 9 divided by 3, which is 126. And the units on this is miles, which is hilarious. You can have a pyramid 9 miles high. But you know, these things are randomly generated, so that's just what happens. The cone, the formula for that is the volume. It's the volume of a cylinder, pi r squared times height divided by 3. So it's pi times 2 squared times 7 divided by 29, divided by 3, which equals 29.3 miles again cubed. Okay, go do some practice and I'll see you on page 35. Okay, we're just going to do a little bit of looking at proportional reasoning in preparation for the next parts 3 and 4. So in mathematics, a proportion is simply two equal ratios. And they're usually written as fractions because it's easier to work with them that way. Proportional thinking is the idea that when things get bigger or smaller, they do so everywhere in the same way. For example, if I make juice from frozen concentrate, I need 3 cups of water for every, 3 cans of water, that should say. 3 cans of water for every can of concentrate. That means if I want to mix up 4 cans of concentrate, I need 12 cans of water because both concentrate and water are multiplied by the same amount, and in this case that's 4, so times 4. This also works with drawings. If I proportionally enlarge a drawing of a lamp, it gets bigger by the same amount, same factor in every direction. That is, if it doubles in height, it also doubles in width. The drawings to the right here are proportional. Right? They look like the same lamp. One is just bigger than the other. In contrast, if I enlarge both height and width by enlarge both height and width by, say, 3 centimeters. So I'm enlarging them by the same measurement. The picture is clearly wrong. They don't look like the same lamp anymore. The drawings to the left here are not proportional. All right. To solve proportions that are numeric just like this, you cross multiply and divide, right? You multiply. I'm going to do one example here. So R equals, you multiply the pair, the two numbers that are diagonal across the equal sign, so 2 times 18, and you divide by the leftover number, which is 12. Okay, so R equals, then you get your calculator out. Doesn't matter where the variable is, you're always multiplying two numbers that are diagonal and dividing it by the one that's left over. Okay, so do that practice and I'll see you on page 37 for the last little example of this booklet. All right, here's an example of a proportion word problem. And this one's actually one of the more difficult ones because you're given the ratio information as 2 to 3, but then you're given the total number of M&Ms. So we actually need to set up a proportion here, or a ratio of child 1 gets 2 M&Ms, child 2 gets 3 M&Ms, and the total number of M&Ms given out in this circumstance is 5, because 2 plus 3 equals 5. That's how many M&Ms we've given out. But the question says we're giving out 80 M&Ms total. So what did we do to the 5 to get the 80? We multiplied it by 16. So we need to do the same thing here, times 16. 3 times 16 is 48. And 2 times 16 is 32. So there's our answers. The first child will get 32 and the second kid's going to get 48. And if we add those together, that does equal 80. Okay? All right, do the rest of the practice and then there's a quiz for you because that's the end of this booklet. Bye.